Alright, so this week we're going to be covering 3.3 dividing polynomials. So far we've learned how to graph, how to add, subtract, and multiply polynomials, so now it's time to divide. So I'm not sure if many of you were familiar with how to use long division with examples like these that we have here, but it's actually pretty similar using long division with numbers and long dividing with polynomials. So let's try and think back to how to long divide in the first place. So using long division, if we have 936 divided by 4, what we want to do is we want to take it number by number by number, okay? And see how many times that this number can go into those. So if we start with number 4, with this 4 and this 9 right here, we want to know how many times 4 can go into 9. So 4 can go into 9 at least 2 times, right? You could have 4 and then another 4 gives you 8, but you can't do it 3 times, right? Because that goes above 9. So we know that it goes into 2 times. So let's write that up here. So 2. So 4 goes into 2 times, so that means when you multiply those together, you get 8. Okay? And now what you do is you take that and you subtract. So we take the 9 and the 8, and we subtract the 9 and the 8, and we get 1. Okay? Now drop down the next number. Okay? So we do the same thing. We just repeat this process until we exhaust everything. So we do 4, and we see how many times it goes into 13. And that's at least 3 times, right? 4, and then 8, and then 12. So at least 3 times. So put that up there. Put the 3 up there. And 4 times by 3 is 12. We're just taking this and multiplying it by that. And then you subtract, and that's going to be 1. Now drop the 6 down here and do the same thing. How many times does 4 go into 16? That's 4 times. 4 times by 4 is 16. And you subtract, and we end up getting 0 in this case. So now we've done everything that we can. I forgot to put the 4 up here. So, because 4 went into 16 4 times. 4 times 4 is 16. So that would be our answer right there. So we know that 936 divided by 4 is equal to 234. Okay. Now let's try it again with number 5. Or with this next one with 493 divided by 5. So notice here that 5 does not go into the first number. We can't, because it's too large, right? 5 is greater than 4. 5 doesn't go into 4. Okay? So whenever that happens, go on to using the next two numbers right here. So 49. So how many times does 5 go into 49? Well, we get 5, 10, 15, 20, 25. Here, 5, 10, 15, 20, 25, 30, 35, 40, 45, and that's about it, because if we go even further, it's 50, and that's greater than 49, so 9 times, right? So 9. So 4 times by 9, or 5 times by 9 is 45, and then we subtract. So when we subtract these, we get 4, and that's going to be 0, so it's just 4, and then drop down the 3. So how many times does 5 go into 43? So 5, 10, 15, 20, 25, 30, 35, 40, and we can't go any more, so 8. And 5 times by 8 is 40. And you subtract them, and you're left with 3, and that's about as far as we can go. We can't take 5, and 5 does not go into 3. And we can't drop any more numbers, right? We can't go any further, so we've actually exhausted everything. So our answer is 98 with a remainder of 3. Another way to write this is that it's 98 plus 3 over 5. 3 being the remainder, and 5 is our what we're dividing by. So that would be our answer, okay? So let's try and see how applicable this is to using polynomials. And you guys might not have noticed, but we've actually divided polynomials before. right? Whenever we say x cubed divided by x, right? When you divide this, it's equal to x squared, right? This is a monomial divided by a monomial, and monomials are polynomials. So notice here that when you divide by a degree of 3 and a degree of 1, you get a degree 2. If you took a degree 3 divided by a degree 2, you would get a degree 1. Okay? So knowing that, let's try number 1 and let's set this up. So to set this up, I would do x plus 1. That's what we're dividing. And then you have this long division sign right here. Now, first thing that you want to do is notice that this goes, your terms right here is degree 3, right? But then you don't have a degree 2 term, it goes straight to a degree 1 to a degree 0. So if this is ever the case, you have to, what you should do is use placeholders. So here I would write 2x cubed, but because there's no x squared in here, just write in plus 0 x squared. Always remember that, because you'll probably forget it at one time and you'll probably get it wrong, okay? So always remember placeholders. And now minus x and plus 1. Okay, and we basically just do what we did up here, right? So what I want to do is think of what I could do. What do I need to do to multiply, what do I multiply this term by to get 2x cubed? So that would be 2x squared, right? If I do 2x squared, and if I multiply that by x, I'm going to get 2x cubed. So that's what you want to do. And write that number up here, or that term. So we have 2x squared. So now what I do is I multiply that by both of these terms right here. Notice that that's what we did here. We would multiply it by that, right? So 2x squared times by x is 2x cubed, and 2x squared times by 1 is positive 2x squared. And we do the same thing, we subtract. So here's the thing though, when you subtract this thing in its entirety, so what we're doing is we're subtracting 2x cubed plus 2x squared. But when you do that, it flips the sign of everything inside, right? So now this is going to be negative 2x cubed minus 2x squared. So whenever we subtract, we have to flip the signs. So now this is going to be subtraction, and this is going to be subtraction. So always remember to flip your signs. And now we can subtract 2x cubed minus 2x cubed, that's 0. 0x squared minus 2x squared is negative 2x squared. And drop what you have over here. So see how similar this is looking to what we were doing before? Now let's repeat the process. What number multiplied by x gives you negative 2x squared? That would be negative 2x. So negative 2x times by, remember I have to take this and multiply it by both of these terms. So negative 2x times by x is negative 2x squared. Negative 2x times by 1 is negative 2x. And you subtract, so that means you flip the signs. Okay, well those cancel out. Now you have 2x minus x, and that's going to be positive x, and drop the sign plus 1. Now, what do you need to do what do you need to multiply x by to get that? And that's just going to be 1. So plus 1. 1 times by x, 1 times by 1 is going to be x and 1. You subtract them. So whenever you do that, you're going to get 0. And that's your remainder. And this is your answer right there. So when you divide them, this is going to equal 2x squared minus 2x plus 1. And the remainder is 0. Okay, let's try number 2. Okay, note here that we don't need to have any placeholders. We go from degree 2, degree 1, degree 0, and then over here degree 1 to degree 0. So we're not skipping any terms. So no placeholders are needed. So set this up, 2x minus 1. And then underneath here is 4x squared plus 6x minus 1. Now what number do you need to multiply 2x by to get 4x squared? And that would be 2x. so write that up here. So 2x times 2x and negative 1 would be 4x squared minus 2x. Subtract them, so change the signs. That's 0. That's going to be 8x, and drop this right here. What number do you need to multiply 2x by to get 8x? That would be 4. So positive 4. 4 times by 2x and negative 1. So it's going to be 8x minus 4. Subtract them, so change the signs. That's 0. 4 negative 1 would be positive 3. Now we can't continue, right? Because we can't find there's no number that multiplies by 2x to give you 3. So that would just be our remainder. So our answer here would be 2x plus 4 plus 3 divided by 2x minus 1. And that's what we did up here, right? We took the remainder, which was 3, and we divided it by that. That's our remainder. So the 2x does not divide evenly into this polynomial right here. We're left with a remainder. Okay, so let's try number 3 now. Think about whether or not we need placeholders. So we go with degree 3, 2, 1, 0. But here we go 2 to 0. So we need a placeholder for the x here. So we have x squared plus 0x minus 2. That's our placeholder. Then we have 2x cubed minus 4x squared minus 3x and plus 3. Okay, what number do we need to multiply x squared by to get 2x cubed? And that would be 2x. And multiply that by each term here. So that's going to be 2x cubed. And that's going to be 0x squared, right? And then negative 2 and 2x would be minus 4x. Subtract them. So change the sign, so it's minus, minus, and positive. Those cancel out. So negative 4x squared plus x, and then we drop the 3. What number do we need to do to multiply this? What do we need to multiply x squared by to get negative 4x squared? That's going to be negative 4. And multiply that by each term here. So it's going to be negative 4x squared plus 0x, because negative 4 times by 0x is going to be just 0. And then negative 4 times by negative 2 is positive 8. Now change the sign of everything. So that's going to go away. Then we're going to be left with x. Negative 8 plus 3 is going to be x minus 5. And that should be our remainder, because we don't know what we can there's nothing that can multiply x squared by to get x. So we've actually that's our remainder is x minus 5. So our answer would be 2x minus 4. And then to write our remainder, it'd be plus x minus 5 divided by x squared minus 2. Which is what this is right here. Okay, you can try number 4 on your own for extra practice, but now we're going to move on to synthetic division, which is another method of dividing, but just note that synthetic division only works whenever you're dividing by a binomial and it looks like this. So a binomial like 5x minus 8, you can't do that. Has to be like x minus 1, x plus 1, something like that. Okay? So synthetic division only works when you have these type of divisors. So in order to set this up, what we want to do is we want to find out, we take x minus 3 and we set it equal to 0 and solve for x. So in this case, we would have to add 3, so x would equal 3, right? So we're trying to see if x equals 3 pretty much is a divisor of this. So what you do is you take that number 3, okay, and I put it up in a corner like that. Now what I do is I write the coefficient, is you write the coefficient of every term that you have, remembering to use placeholders. So in this case, I'm going to write -1. That's the coefficient of the first term. Then 4. And note that we don't have an x variable. So you're going to write 0. That's the coefficient of that term. And then 9. Okay? And then put a line through like that, remembering to leave space right here, because we're going to write underneath that. So we set this up how we need it to. First thing I do is I drop the -1 right there. Now I multiply anything down here with what we have in this box right here, okay? So -1 times by 3 is -3, and I'm going to write that in these spots right here. So -3. Now I'm going to add these together. So for -3 is going to be +1. Now again, I'm going to repeat the process. I'm going to multiply this by 3. So that's going to be 3 right there. 3 and 0, if you add them together, is 3. Multiply these two together, you get +9. Add them together, and you get 18. So whatever you get in this last spot is your remainder. Now remember that we're dividing a polynomial of degree 3 with a polynomial of degree 1, which means we're going to get a polynomial of degree 2. And these are your coefficients. So that's pretty much what we just solved for. So we have -x² plus x plus 3 plus the remainder, which is 18 over x minus 3. And that's pretty much all you need to do for synthetic division. So it's pretty straightforward, right? So let's go to number 6. So if this is x plus 1, that means the number in my box is going to be -1. And, excuse me, had to sneeze. Alright. And so now we write the coefficients, remembering to use placeholders if you need them. So this is going to be 3, -2, excuse me, 2, and -5. Drop this number right here and multiply that with that number up there. So 3 times -1 is -3. Add these numbers. Sorry, don't know what happened there. Okay, so -3, -2, -3 is -5. -5 times -1 is +5. 5 and 2 is 7. 7 times -1 is -7. And you add those, you get -12. So we have a remainder of -12. And then remember that we're dividing a polynomial of degree 3 with a polynomial of degree 1. So we're going to have a polynomial of degree 2. And these are the coefficients. So 3x² minus 5x plus 7 minus 12 over x plus 1. There you go. Now one more for practice. So for number 7, if this is -7 here, then we're going to put 7 up here. Now write the coefficients. So we have 1, -4, -15, -42. Drop the number here. So 1 times by 7, 7. 7 and -4 is -3. -3 times 7 is -21. -21 and 15. It's going to be 36. Sorry, I have one of my numbers wrong. I was wondering what was up with that. So this is actually going to be, so that's going to be positive 3. That's not negative 3. Sorry about that. So then that's going to be 21. 15 and 21 should be, so 21 minus 15 should be 6. 6 times 7 should be 42. And then that's 0. So we have a remainder of 0. So then our answer will be x squared plus 3x plus 6 with no remainder. So basically what we just say here is that this x minus 7, this factor, divides evenly into this polynomial. Okay, so synthetic division is pretty easy, right? Just remember that you can only use it for certain examples. Now, just to finish up is to cover up what the remainder theorem is. So basically what we're saying here in the remainder theorem, if I were to put this into English right here, is that if you have something like this right up here, like what we've been using with x minus k, then your remainder is actually what you get when you do f of k. So as an example, first of all, let's use synthetic division here. So when x is negative 4. So we put negative 4 up here, right? And then we put this, what we have right here, we get 5, we write down the coefficients, negative 1, 13, and 29, right? And let's write this out. So we drop the 5. So 5 times negative 4, it's going to be negative 20. That's going to be negative 21. So 21 times by 4 is 84, so that should be positive 84. And then add 13 to that, so we get 97. And that times by 4 is negative 388. And then add 29 to that, and that's negative 359. So this is our remainder, right? So now going off track a little bit, what if I take negative 4 and I plug that into my x value? So if I did f of negative 4, so what happens when I do that? So we get this is equal to 5 times by negative 4 cubed minus negative 4 squared plus 13 times negative 4 plus 29. Okay, now to solve for this, this is going to be 5 times by negative 64, I believe that is, minus 16, minus 13 times 4, which is 52, plus 29. And then 5 times by 64, that's going to be negative 320, minus 16, minus 52, plus 29. So if I take all of that and I add that up together, so 29 minus 52 minus 16 minus 320, well, I'll get negative 359. So look at that right there. These are the same. We get the same result. So that's what the remainder theorem pretty much says, is that instead, you don't really even have to, that if you just want to find the remainder, notice that whenever we did this, we just found the remainder. We didn't find the coefficients for the polynomial. We just found the remainder. So if you're just looking for the remainder, you can just plug in the value and solve for it. Which also means that if it goes in evenly, so if you end up getting a remainder of 0, then that means that this factor right here divides evenly into it. That's pretty much all it's saying. So I feel like we've gone through a lot of practice problems. So if you guys want, you can go through these or go straight to your homework, depending on how much practice you feel like you've gotten. But just try and freshen up on these examples. Use synthetic division here, and then all we're saying here for number 13 through 16 is that in exercise 13 through 16, use synthetic division to evaluate the function for the indicated x value. This is just, I don't know why, this is really nothing different from what we've been doing, just using synthetic division, but if you do this, you get 2. So if you have 2 right there, then you write down the coefficients. It's going to be -3, 4, -17, and -6. You drop the -3. So multiply those, you get -6. When you multiply those together, add these together, you get -2. -2 times by 2 is -4. 17 and 4 is 21, so -21. -21 times by 2, it's going to be 42. So -42. And then 6 to that is -48. So basically, use synthetic division to evaluate the function for the indicated x, value of x. Well, there you go. It's the same thing. We just have -3x squared minus 2x minus 21, and then a remainder of -48. So that should cover everything for division. Hopefully it wasn't too bad. But yeah, it's pretty straightforward, pretty easy. Use this extra practice problems for more practice. If not, if you feel ready, just go straight to the homework. Email me if you have any questions or talk to me in class. So I'll see you guys then.